In number 17, we're going to add two radical expressions. And let me remind you that we can only add like radicals. So for example, let's say 3 times the square root of 5 plus 4, excuse me one second, plus 3 root 5 plus 4 root 5 is equal to, just add the 3 and the 4, is equal to 7 square root 5. All right, if we had something like 3 plus 4 root 5, we can't combine. Okay, so we just, these are not like terms, so we leave as is. Or if we had 3 root 5 plus 4 root 7, also we just can't combine, leave as is. All right, so in number 17, we have two radicals which aren't like radicals. So usually in this type of problem, what we try to do is we try to simplify the radicals so that we do get the same radicals, so that we get like radicals. So we're going to simplify each. Start by simplifying whichever one is easier. So maybe we'll start with 18s because it's a smaller number. All right, so that would be, the factorization would be 9 times 2. All right, and we'll pull out the 9 as a 3, taking the square root of 9. So we see we're left with 2 underneath. That's the important thing to realize here, because now we know how we want to factor square root 98, or how we want to factor 98. We want to be left with a 2 underneath the radical. So let's factor 98 as 2 times something. All right, so 98 is 49 times 2, which is good, because 49 is a perfect square, so we can pull it out as a 7. So you see how it's good to start with whichever radical is simpler to simplify, and then we get a hint as to how to simplify the other one. All right, so let's multiply 3 times 5. So we have 15 square root 2 plus 7 times 3, we have 21 square root 2, and now just add the coefficients. 15 plus 21, so we have 36. 36 square root 2. In number 18, we want to subtract two radical expression. This time we have cubed roots. All right, so we want to simplify these. And we need a factorization that's a perfect cube times something else. So let's start with 24. 24 is 8 times 3. 8 is a perfect cube. All right, so this can come out as a 2. Remember, 2 cubed is equal to 8. All right, here we want to be left with 3 as well. And 81 is 27 times 3. And 27 is a perfect cube. All right, so that will come out as a 3. 3 cubed is 27. Okay, so here we have 10. 2 times 5, 10 cube root 3. Minus 4 times 3, minus 12 cube root 3. And now subtract 10, subtract 12, and we have minus 2 times the cube root of 3. In number 19, we're rationalizing the denominator. That means, what does it mean to rationalize a denominator? Well, right now the denominator is irrational, because we remember back in chapter 1 we learned that the square root of 3 is irrational. The square root of a number that's not a perfect square is an irrational number. So if we rationalize the denominator, it basically means get rid of the square root from the denominator. All right, so we have a way of doing that. Let me just rewrite this expression. And what we're going to do is we're going to multiply top and bottom by square root 3. Okay, if we multiply top and bottom by the same number, we get an equivalent fraction. And square root 3 times square root 3 is equal to 3, just 3 without the radical symbol. So that would, in effect, get rid of the radical and rationalize the denominator. So we have 5 root 3 times root 3 is 3. All right, so we get 6 root 3 over 15. Now, sometimes we could reduce this. In this case, we can divide top and bottom by 3. And we have 2 root 3 over 5. And number 20, again, we want to rationalize the denominator, get rid of the radical from the denominator. Now, if we multiply by square root 5, this won't do it, because we're going to do the distributive law, and the square root 5 will end up right here. Okay, so we can't multiply top and bottom by square root 5, but we do have another trick. Remember when we did multiplication of this type of radical expression, we FOILed them out. We saw that when we multiply conjugates, the radical basically disappears, or the product doesn't contain a radical. Okay, so let's multiply top and bottom by the conjugate of the denominator of 2 plus root 5. The conjugate is the same thing with a different sign in the middle. So instead of 2 plus root 5, the conjugate would be 2 minus root 5. So these two are conjugates, and we have to, in order to get an equivalent fraction, we have to multiply numerator and denominator by the same thing. Now it's easiest to multiply these denominators. Let's do that first, because we know that the middle term, the outer plus inner, they're of opposite sign, and they're going to drop out. So we only have to do first last in the FOIL multiplication. First is 2 times 2, so we have a 4 there. And again, let's just see, outer is 2 root 5, outer is minus 2 root 5, inner is plus 2 root 5, so that's 0. So let's go straight to last. Root 5 times minus root 5 is negative 5. So in the denominator, we get 4 minus 5, which is rational. We got rid of the radical. All right, let's multiply. We'll FOIL out the numerator. So here we do a complete FOIL multiplication. First times first, 3 times 2, that's 6. Outer is minus 3 root 5. Inner is minus 4 root 5. And last is minus 2 root 5 times minus root 5. So that would be plus 2 times 5. Remember, root 5 times root 5 is just 5. Okay, so what do we have over here? In the denominator, 4 minus 5. In the numerator, okay, 2 times 5, that's 10. So first we have 6 plus 10, so that's 16. And here we have minus 3 root 5 minus 4 root 5, that's minus 7 root 5. Now we shouldn't leave our answer like this. On the multiple choice test, we wouldn't see the answer written in this form. What we should do is divide through by that minus 1. Or you can think of it as multiplying top and bottom by minus 1. So here we have 16 divided by minus 1, it's minus 16. And minus 7 root 5 divided by minus 1, that's plus 7 root 5. In number 21, we're simplifying a radical expression that contains a variable. So here we have 18 as a coefficient, and we'll simplify that as usual, factor, where one factor is a perfect square, so that would be 9 times 2. And we're going to factor x cubed in the same way. We want a perfect square times whatever remains, so that would be x squared times x. And then I'm going to circle the 9 and circle the x squared, because those are the perfect squares. And bring them out as 3 and as x. So we have a 3x in front of the radical, and we're left with 2x inside the radical. So that's simplified. Okay, let's simplify number 50. So first factor 50 as 25 times 2. Now how about x to the 5th? Well, just subtract 1 from the exponent. We have x to the 4th, which is a perfect square. So that would be x to the 4th times x. And y to the 7th, again, we're just going to pull off one y. We have y to the 6th perfect square times y. Now let's circle the perfect squares. It's important to be very neat here so that we don't leave anything out. And so that we know what is left in as well. Okay, so let's pull these out. 5, square root of x to the 4th is x squared, and the square root of y to the 6th is y cubed. Remember, just take half the exponent. So in front of the radical we have 5x squared y cubed, and left inside we have 2xy. Number 22, we're simplifying a cubed root this time. So we'll start by factoring 128 into a perfect cube times something else. We'll just divide it by 2 and we have 64, and that is a perfect cube, so the factorization will be 64 times 2. Alright, now we come to x to the 4th. Well, x to the 4th can be written as x cubed times x, and x cubed is a perfect cube. And y to the 5th can be written as y cubed times y squared, and y cubed is a perfect cube. So let's circle our perfect cubes. 64, x cubed, y cubed, bring them out. 4 cubed is 64, bring out a 4. Here we're bringing out an x, and here we're bringing out a y. So in front of the radical we have 4xy. And inside we're left with 2xy squared. And in number 25 we're simplifying a fifth root. Alright, fifth root of x to the 28. So we want to factor x to the 28 into a fifth power times something else. So if this exponent were divisible by 5, we would have a fifth power. So what we're going to do is keep subtracting from 28 until we hit a fifth power. Okay, well, we'll keep going down. 27 is not a fifth power, 26 isn't a fifth power, but 25 is. So we'll factor this as x to the 25. 25 is the largest multiple of 5 contained in 28, so x to the 25 times x cubed. And let's circle that and bring this out. And what do? Divide the exponent by 5 to get the fifth root. So that would be x to the 5. Alright, so this simplifies as x to the 5th times the fifth root of x cubed. Let's just do one more like this. Let's say we want the fifth root of x to the 32, y to the 63. Alright, so we want to factor x to the 32 so that we have x to a power that's a multiple of 5. Alright, so let's look at 31. Keep going down one. No, 31 is not a multiple of 5. And then we have go down one more to 30, and 30 is a multiple of 5. So we'll factor this as x to the 30 times x squared. Now, y to the 63, well, the largest multiple of 5 contained in 63 would be 60. So we'll factor y to the 63 as y to the 60 times y cubed. And now we're going to take out x to the 30, take the fifth root of that and the fifth root of y to the 60, divide those exponents by 5. Alright, so 30 divided by 5 is 6, so we have x to the 6 on the outside. And 60 divided by 5 is 12, so we have y to the 12 on the outside. And inside we're left with x squared y cubed.